Welcome to qnawire.
Question 42 asks to imagine that a sprinter accelerates from rest to a maximum speed of 10.8 meters per second in 1.8 seconds. In what time interval will he finish the 100-meter race if he keeps his speed constant at 10.8 meters per second for the last part of the race? What assumptions did you make? Okay, so we're going to break this down into a few different sections, but just to generally describe what's happening here. So we say that the sprinter starts from rest. So here, if we're plotting a velocity in meters per second versus time graph in seconds, of course, the sprinter starts from rest, accelerates for 1.8 seconds. So I'm just going to call this 1.8 seconds, of course. Once he's done accelerating, he travels at a constant velocity, which is given as 10.8 meters per second. So the way we need to solve this question is to recognize there's two distinct parts to this, right? The part of acceleration and part of non-acceleration. So I'm going to state what we have given for each segment, and we'll find out what we need to determine in order to find our overall goal, which is the total amount of time required, right? What time interval? So our goal solution is to solve for time total. Right, so if I call this first segment 1, second segment 2, this is a bad question mark, by the way. Oh, well, you get the idea. In our first segment, we know the time for T1, that's 1.8 seconds. We know the initial velocity, does it say from rest? Starts from rest, yep, so that's 0 meters per second. We know the final velocity, which the runner reaches, which is the velocity for part 2, which is 10.8 meters per second. We don't know the distance for part 1. That's about it. Okay, for segment 2 now, but maybe I'll do in green just to make it a bit obvious what I'm working with. Segment 2, excuse me, time of 2, we don't know. So we don't know how long it takes from the start of segment 2, excuse me, to the end of the race, because if we did by now, we would solve for T total, obviously, so we don't know that. Our initial velocity is the velocity the runner reaches, excuse me, at the end of segment 1, so that's 10.8 meters per second. Our final velocity, well, we're not accelerating, so of course that's 10.8 meters per second as well. The distance for segment 2, we don't know either. Right, but also we know, oh, I should say for the first part, but we know the acceleration for this part is 0. Where the acceleration for part 1 is non-zero, but we have to calculate it. Which that may be, hint, our first part we need to do. So A1 we don't know, A2 is 0. Ooh, wrong color. A2 is 0. Okay, so we have a few unknowns here. Again, our total goal is to solve for T total, which if you think of it, is just T1 plus T2. So there's a goal there. We need to solve for T2. Oh, one thing I should also note is that we do know the total distance of our race is 100 meters. So we know that, of course, that's D1 plus D2, which we don't know, but if we solve for one, we can solve for the other. So, okay, again, starting from this point, T1 we know it's given to us, T2 we don't know. So we could represent this as saying T1 is okay, T2, don't know T2, but we know we can maybe represent in terms of distance and velocity over V2, right? Distance 2 we don't know, velocity 2 is just the velocity traveled in that segment, which we do know. So really all we need to solve for in this problem is solve for D2, the distance of part 2, which will give us our total amount of, our total time for T2, which will solve for our total time. Okay, so how do we solve for D2? Well, again, looking at this equation, if we solve for d1, we know d2 is just 100 meters minus d1. Okay, well, how do we solve for d1? Well, we're given information that can help us determine that. So I'll do that in black here. So for part segment 1, solving for d1, we know that our distance 1 can be represented as our initial velocity times time for segment 1 plus 1/2 a1 times t1 squared. So we can solve for d1 here. However, we don't know a1 yet. But we know that a1 can simply be found by the change in velocity over time. Well, velocity initially is 0, so we can represent this as 10.8 meters per second over 1.8 seconds, which results in acceleration of 6.0 meters per second squared, which we can plug into our equation here for d1, where we can find that d1 initially velocity is 0, so don't need that term. So we have 1/2 times 6.0 times t1 squared, which is 1.8 squared. So we can find the segment length of part 1 to be 9.72 meters. 9.72 meters. Great. So now, that's all we need to solve. So now we can use the total time equals the time segment from part 1 plus, again, this representation here, d2 over v2 is simply 1.8 seconds plus the segment for d2, which is 100 minus d1, right from here, 100 minus 9.72, all in terms of meters, divided by the velocity of segment 2, which is known to be 10.8 meters per second. We solve for this, we find that the total amount of time to two significant figures is simply 10.2 seconds, which we can round to 1.0 times 10 to the 1 second. And there you go. So a bit of a complicated problem, just determining what parts of the question do we need to solve for in order to solve for time. Well, we know the relationship for total time, t1 plus t2. That can be solved by just looking at the distance for segment 2. But in order to find the distance for segment 2, we need to find the distance for segment 1, which you can find based on the acceleration to get d1, to get d2, to get final time. And there you go.